We're on. Quick note: last week's lecture did not record with audio, unfortunately, as you probably some of you have found out. So, unfortunately, I can't go back in time and save an audio file. So you'll have to just pretend that I was talking, and then you can figure out what's happening. This week we do have audio, and I can tell you that because if you look at the little green bar there, it's fluctuating when I talk, and if I talk in real good teacher voice, I can make it loud. It gets red. There we go. So if I'm really angry, it turns red with me. And that's the thing. I have no reason to be angry. So, how's it going? All right, welcome back. Just a couple things from class notes. Number one, many of you have already done this. As you can tell, my Blackboard is blowing up with notifications. But if you haven't figured out where to submit the homework yet, under Blackboard, if you go to under Activities, working, it's buffering. My son knows how to say that. It's buffering when it's waiting. I'm just impatient. Let's go. There we go. Ha! This is not student preview, but if you go to Activities, there is a homework number 1 link. You click that, and you should be able to upload your file with a attached file, browse my computer. For those of you who use Blackboard for homework delivery, do any of you know how to allow you to resubmit a copy? I asked this because several of you have submitted things. You're like, oh, can I go and do something different?
You have to edit the actual assignment.
I tried doing that, yeah. And
At the very bottom, there's a box that says allow multiple submissions.
yeah, okay, let me see if I can do this. Is that under Grade Center?
Go into the activity. No, go into the activity.
Activities right here?
Yeah, and then go to homework 1.
Homework 1.
Edit. Yeah, edit.
Edit, thank you. And this is allow multiple attempts. Submission details. Single attempt. Ah, there we go. Multiple attempts. Here, I'll just do unlimited attempts. You can just... I've been there before. I know how it works. Things are due at 11:59 tonight, so you still have time. Although it seems like if you're still working on it, you're welcome to do that today in class as well during our class time. So those of you who asked me if you could redo it, now we have help. Thank you, Sammy. Thank you. Who else was saying? Thank you to all of, Juhi, thank you. Thank you all for your help with me in Blackboard. I don't know about you, but so I like to think of myself as knowing a little bit about computing. I'm not super awesome or whatever, but you know, I've been able to make my way around, and Blackboard is one of the least intuitive things to go and find. And then if you click help, it's like the R help. Right. Yeah, this doesn't look like your version of Blackboard? Yeah, no shit. Anyway, so... Jesus. You know what I'm talking about, right? So R help is that way too. So I'm trying to say this because you're doing an R assignment, and how many of you felt frustrated with R? That's good. Did anyone feel no frustration with R? Okay, that's the best way of asking. Look around. All right, including me. All right, so if I'm venting about Blackboard, does that help you look like we're on the same playing field here? Like we all have, is that cool? Okay, so there we go. So that's how to submit homework 1 if you haven't done so yet. And those of you who did ask to resubmit, you are now able to do multiple attempts. Hooray. Okay. The other part with homework 1, my intention for grading, I'm going to be fairly lenient with it because I don't really like to take off points that much unless there's a clear reason. But I'm also going to give you my version of the answers. And because there's 38 people enrolled plus several auditors who've submitted things, I don't think I'll be able to give you as much personalized feedback with your file. I'll try to if I can. But the homework that I send, the file that I send back, take a look at it, see if you can get it to run, take a look at the syntax. And of course, anytime you have questions about that, shoot me an email. shoot me an email or you can find me during office hours or however. Okay? Sarah.
On the homework portal, will you include our points from this homework on that portal?
Yes, that's what we're going to get to in just a moment. Absolutely. Let me talk about that just a moment. And let me tell you a little bit about plans for what's coming up here real quick. I've got my, if you want to play along, I've got my list of notes here. Actually, you can't see my iPad. So my notes about what to talk about before class, because normally I use my lecture slides as sort of my outline for what to talk about. So now I realize I need some type of structure in life and class. If we go to my website, our course website, what you'll note is that I am taking what we're doing in interactions and slowing it down a week. And the reason for that is this first, or the second homework, the homework that's the first online homework, is going to be a challenge. It's just very difficult. It's in theory stuff that you've had in your previous class in regression and ANOVA, but it's sort of amped up to a level that's pretty like advanced user, right? So to do that, to make it so that you can focus on it and not have to take additional material with it, I am not giving you anything to watch this next week. Okay? There is a quiz. There will be another quiz. It'll be on interactions and the homework and everything else. It'll be another 2-item, quick little deal that you can do pretty quickly. There are lectures from previous courses where I've given this homework, some of which that my spouse is in talking about. So you can see those lectures and try to glean any bits of information from those as well. But that's what's coming up for the class. The other thing I'll note is that means I'm going to sort of bump off the last topic of the class. But again, when we get to that part, I will have links to other materials that I've done before. I've taught a class on the topic before. So if you want to learn more about it, you can go in there on your own with stuff I've done before. I know it's not ideal, but hopefully it'll give you a little bit more information and something that you can to go with if you're really interested in clustering and classification. But right now, my biggest concern is I'd like for you to get the primary premise of this class, which is sort of what happens in math and stat classes. Have you many of you taken those math classes where, like, if you took like Algebra 2 or pre-calculus, sorry, Algebra 2, let's take that for an example, right? When I was in high school, I got a nice big F in Algebra 2. You know that about me? That's claim to fame. I went on to pre-calculus and got a D-. Somehow I got better. But I had no time for math, and math didn't seem to make any point. Bigger picture, though, I had to take it in college. Had to take remedial math to start, and took college algebra, and then I realized I took a stat class, and I loved it, and I want to do this for a career because it's amazing, right? And math had purpose, and my life had purpose, and everything was good. I was like 18 years old, and amazing. And then I decided I needed to do math, and so I started taking all the math classes. And so sure enough, like Algebra 2, you get certain skills in, but then you don't really get those skills well until you take the next class along, right? So the prerequisite for this class is 810, which is supposed to be linear models, which is mainly regression, some ANOVA, right? Most of you took that or something equivalent to that. But I look at that as sort of the same idea, that you take that class to sort of understand the basic premise of it, but now is where you get really good at it, right? And so that's where the next homework is. And so to focus on that, I really wanted to slow down what I'm giving you for concepts right now by a week, because this homework is just, again, notoriously difficult. Don't let it demoralize you. It's tough. So let's talk about that. Sarah had mentioned our online homework portal. I didn't put a link there. I should have one. But if you, here. What's that? The week. Okay, that's good. At least I put it there. Here, I'll just quickly put a link before I forget, because I forget these things all the time. Here, I do href equals. You can just watch me do some HTML. I can't type. Here we go. We are going to do one of the examples of this today. Coming up here, so. Here, finally. Okay, awkward silence apart. It's all right, I like being awkward. It's sort of a pastime of mine. You know what I'm saying? It's okay. Like now that people have T-shirts that they're making, what's like I'm awkward and stuff. It's like, yeah, I could do that. All right. So you can click on the links on the page. If you refresh your page, you should see links at the bottom, or it's in the text for this week. And up pops the Hoffman Homework Hub, which is a terrible name. By the way, my wife's last name is Hoffman. My last name is Templin. But our son's last name is Hofflin. We decided to put a brand new name together for him. And yes, you can actually do that. So I don't know if you've seen that before, but this whole hyphenated last name thing, while cool, acknowledging both parties responsible for the child, there's only so many generations you can hyphenate between like having, you know, running out of like time to say it. So we decided to create a portmanteau of our names together. Isn't that the right word, portmanteau? A name that puts together of our names for him. But yes, under our class, Multivariate Analysis, you'll be able to see a sign-in page. The sign-in page works like this. Let me get my KU ID card out. No, that's not it. Where is your 7-digit ID for KU? Anyone know that? It should be on your ID card. Not on here for me, I don't think. Anyway, oh wait, there it is. Nope, it's not. Okay, you have a KU ID. I can see it in Blackboard. That's how I get it for each of you. But if you put in your last name, you put in your 7-digit ID, you should be able to pull up this homework system. Now I'll note the way this works, the point totals that you see on this thing aren't going to be current and up to date because they take me having to go and refresh them every so often. And so if you see your quiz total, and it doesn't include this week's quiz, it's because I pulled stuff down on the 28th, which was like this weekend. So it's not going to be as up-to-date as Blackboard. I'm going to try to have everything up in Blackboard for your grade since we're using it a little bit more. So this is just sort of a rudimentary thing. You'll see there's a homework 0. Homework 0 is all extra credit. And you can click that. And this is how the homework system works. And actually, you're welcome to do this. Follow along with me right now. Get your 5 points. This is actually going to be due, doesn't say, I believe it's due like next week. This is due next week, although this is a easy assignment that you can do right now. But how many homeworks do we have planned for this semester? 8. So if you put 8 in, hit enter, 8 will turn green. Hooray! If you put another number in that's not correct, it'll turn red. So for instance, how many points total are these homeworks towards your final grade? There's 72, but let's imagine I didn't see the syllabus or the website and I put 70 in, and guess what it does? It says, nope, it won't take that response. So you immediately know for these types of questions, which we call computational questions, that you are either correct or incorrect on the homework. And the reason for that is, in many of these statistics classes, you've taken them before, how the assignments work. There's usually some type of question or set of questions directing you to do a series of analyses that are sort of chained together with something like 18 steps. And what happens if you go awry on one of those steps? They all go downhill. And do you know whether you went wrong? No. So we're going to use properties of statistics to ensure that you're not going wrong on the steps of the analysis, so that you get the analysis right first for each of the homeworks that you do, and then you can talk about doing a results or discussion. And the idea of mirroring what you do in an analysis when you build your research study or your dissertation or your master's or something that you're going to submit to a journal article. You've got to, for quantitative analysis, you sort of do your steps of analyses, potentially in an R file with script that you can rerun if the data changes or if someone wants to replicate the results. You answer a series of questions to make sure the models are right, and then you go write it up, right? So that's the plan for homework as well. So let's just put 72 in here. How many points will you lose if you complete each homework even a minute late? So this is the other thing about the homework assignment system. Its due date is hard-coded in a database online, and so if you submit it at 12 p.m. or 12 a.m. when it's due at 11:59 p.m., it'll deduct 4 points. 4 points from your homework. And the reason for that is to motivate you to stay on top of things, but also because we want to try to provide feedback to everybody right after the due date. So the due date hits, you can go log in 1 minute afterwards. You can see the results. You already see the green and red boxes. There are some results that you won't be able to see the answers of until after the due date. So this after the due date helps you to see your results and be on top of feedback for the class immediately for how this works. How are we doing so far? Sound okay in concept? Okay. How many points of extra credit is completion of homework 0 worth? It is worth 5 points. All right, so we got through the computational questions. Hooray! They're all done. We got all points. Now comes the next section. The next section is a results section. It's when we get into homework 1 or homework 2, you're going to see this is meant to mirror a results section that you'll have for the type of analysis that you're going to do. So if you're busy going to be doing some type of linear model, regression, or ANOVA for some type of research project you're doing, you're welcome to use this as a template for your results. Right? It's fine. One of the other things we found is it's really hard to do as an instructor. First of all, with a class this size, but even without a class this size, it should be 10 people. If each of you is writing an individualized results section, we're trying to provide feedback for that at the level of the question. It's very hard for us to get feedback to you that you can interpret and understand because it takes a very long time to do that. So what we thought a good way of doing this would be to build a results section you can emulate online. They're very formulaic for a lot of the types of analyses you do. In fact, we could even, those of you who want to try this, maybe you can even find a package. You could write an R package that creates results sections for linear models pretty easily. I kid you not. Like, you could just have it just generate text for you. There are people who've developed APA SPSS macros that try to do this with linear models. So think about that. Talk about how writing results sections being quick. Details. So this is an example. It's results, but there's drop-down boxes. So it's like Mad Libs. Remember Mad Libs? They still have. I know they still have Mad Libs. And if anyone doesn't know what Mad Libs is, go ahead and Google it. It's like a book or a thing that I used to do growing up, where they would ask you for certain parts of speech, like a noun or a favorite color or a number, and they would interject what you said into a story, and it would just make usually no sense or it'd be somewhat funny. This is more supposed to be for results, key results. My office is located, anybody know the answer? 614. My office hours are held in 614 as well. And they are held never, no. Usually Mondays from 1:30 to 4:30, but check the online schedule. So the results sections that you're going to see for the homeworks coming up, the results themselves will sometimes populate with numbers that you'll put in from the computational section. Typically in a results section, you'll be talking about, the main effect of this was 2 point whatever, or the standard error was 3 something or other. So when you're doing your homework, complete the computational questions first, get those to turn green, and then the numbers from the green boxes will just automatically populate into the results section below, so you'll be able to read it more contiguously. Cool? The computational questions, well, there's another section, for instance, how many points from online quizzes count towards the total of your grade? Anyone know? 30. How many days a week does this class meet? This is me testing it. 23. No, 1 day that we meet, although I feel like I do this every day. Every day of my life is something. It's like brushing your teeth. You got to do a little multivariate every day of your life, right? No? Okay, maybe not. Flossing, maybe? No, I'm just kidding. Oh, come on, Never mind. I floss all the time. So, R is free. RStudio is free. Hooray. Now, it says check and save your answers at the bottom. You'll note that the answers that you select from the drop-downs that are in the results section or the multiple choice section, if there is one, they won't tell you whether you're right or wrong. Right? This is sort of the part where we take the training wheels off and we say, now you've got to go and interpret it. So I want you to try to think about those, think very clearly. That's where you try to take the numbers where they make sense and try to understand what they're doing. When you're all done, though, you have to click this submit. This is very important because there are people who Every year we have this happen where people forget this step. When you're all done with this, your homework, and you're ready to submit, you have to go to Submit Final Answers at the bottom, and you have to enter your password, which is really just your KUID, one more time to enter it. And then it'll tell you, okay, your answers have been submitted, and it'll tell you when you can log in and see the results for good. Okay? So just remember that last thing, that last step. If you don't hit submit, it will look like you didn't fully finish the assignment, and then all sorts of problems happen with databases and so forth. So at the end of it, please, 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 please submit your assignment. Cool? Questions on this? How many of you just completed homework 0? All of you did. Hey, you just got bonus points. So all that frustration for R, this was pretty good, right? Did you hit submit? Okay, you did that. Great. Let's talk about homework 2 then. Because homework 2 is going to dominate the discussion for the next week or two. Okay? Homework 2, first of all, everybody gets their own data set. This is an individualized data set for you. Each of you will have different results, this means. That means there'll not only be different numbers in the green boxes, there may be a different set of pattern of results in the drop-downs as well. Why I like this is because if you choose to work together, that means now you effectively have to generalize what you're doing to understand the process. And so working together is fine. Just know that you're going to have 2 sets of answers you're going to have to complete together. Cool? Cool. So there's the data file that should download. It's a CSV file. We're all familiar with those now, thanks to Make Friends. Make note of where it downloads. If you click on the next link, you will find Starter R syntax. All right? So this is something we can copy and paste, but here's what I'd like to tell you to try to make things a little bit easier. If you note, I downloaded that CSV file, and it's in my downloads folder. Remember, this is about file paths. Remember the frustration about file paths? If you remember which folder you put that file in, if you go and create a blank R script file in RStudio, hang on one second. This is my package I created to actually create the homework system. Yes, I want to close that one now too. But if you go to a blank R script and just save it into the folder that has the data. So for instance, I'm just putting this directly in downloads, calling this HWO2. And then I'm going to close RStudio. Done, right? So now what I have in my folder is data, and I have homework 2, right? If I start up homework 2 here, you'll find homework2.r. It's a blank R file. Go back to the page that has all the R script. Copy it. Paste it into R. Okay. Right, save it. Now, what you have to do is modify your ID number at the top. I'll put mine in. You can see my ID. Or is that my ID? We don't know. Since I create the system, that right there is my social security number. No. 7 digits of it somewhere. No, maybe not. That's not quite right. Anyway, if you put all this in and save it, because the data file and the R script file are in the same folder, when you double-click the R script file to open it directly in RStudio, RStudio's default working directory is the same as where your data is. So now it's just a matter of reading in the data file with just the name of it. So this script should work to read in the file just like I did right there. Okay? So what I'm trying to do is to make your life a little bit easier to automate what you need to do the homework in R, right? You got data. We have a script to read it in. Not only are we reading it in, I'm creating the variable names for you. I'm doing some of the steps of the homework to make this work. And so let me go through what those steps are really quickly. So here, if we take a look at the homework assignment. Now this is sort of just going to read this. Forgive the poor attempt at humor created by our statistics. Well, this is my wife created. Elisa Hoffman created this, so clearly not my fault. No, this was heavily inspired by life events that happened a while ago. But this is this homework assignment focuses on a study conducted in the Department of Recreational Sciences to meet two objectives. First, the investigators wanted to examine the extent to which performance in miniature golf could benefit from a new approach to skills training, as well as the extent to which training in related activities, such as regular golf, might differentially impact performance. Now, those of you, how many of you have played miniature golf? That's great. For those of you who don't know what it is, it's just like putting, like the game of golf. It exists in many cities in this country, although it's very hard to find in Lawrence, although there is a place, I don't know if it's still there, 23rd in Louisiana, there's an indoor small little course for it. In my family, I have two younger sisters, and we sort of have a little bit of a healthy competition, and I'm from Northern California, so when I go back there, we go to this championship-style miniature golf course, which is extremely difficult with like water hazards and trapdoors and stuff, and I'm proud to say I beat one of my sisters like for 30 years in a row, and she finally got me in my my early or my mid-30s, and I was like, oh my goodness, what happened to me? I'm falling off. But then I finally gotten her ever since then. So just I'm only have one loss to her. It's like the Harlem Globetrotters against the Washington Generals. That being said, if you want to improve your golf performance, this is a study for you. 200 students at Midwestern Red State University, narrow that one down, were randomly assigned to one of four conditions: a control group, which is group 1, a miniature golf training group, which is group 2, a regular golf training group, which is group 3. Those of you in HSES, anybody else? Nope, just one HSES student. Oh. Some of you, like, they teach classes on like sport there, right? I don't know. Anyway, regular golf training, and then finally a training group that had both training in miniature golf and regular golf, right? So you see the design. We want to see if the training program for miniature golf improves your score, if the training program for regular golf improves your miniature golf score, or if some combination of the two improves your score, right? Kind of makes sense? So the dependent variable is the number of strokes taken on a high-stakes 18-hole round of miniature golf held at the conclusion of training. So this is the DV. It's your score. But remember, in golf, or those of you who aren't familiar with golf, let me try to describe it to you, lower scores are better. So some of the questions are going to say, did this improve the result? So you want negative numbers to improve the result. I've tried to put text around the question to try to help you understand that a little bit. Okay? So we got the setup so far. We have this experimental design. We've got 4 groups, 50 people in each group, assigned at random. Of course, because it's miniature golf, everybody wanted to sign up. You got a great. Our SONA system for this was amazing, right? We have one of our administrators here in class. We're lucky to have her. Second, the investigators also wanted to examine the effects of experience with and enthusiasm for the sport of mini golf. So we know this experimental study we're going to do, we know people are going to come to it with different levels of experience. If you're like me, and it was like the one thing as a family we like to beat each other up over, it's a big deal to you. You have a lot of experience in miniature golf. Those of you who've never done it before, probably not. It's probably going to make a difference, regardless of our little training program, right? The other thing is, if you don't like miniature golf at all, but you're signed up because you need extra credit for your class, your enthusiasm might matter, don't you think? The more enthusiastic you are about miniature golf, the more you're probably going to try. Otherwise, you're going to be like, I don't know, those of you who play regularly, where did you pick up the ball? I don't know, we had a 6-stroke limit. You got to 6, you had to take the ball up and go to the next hole. Anybody else? Oh, wow. Yes, it does. Especially those like volcano holes where you have to, yeah. So not to make this worse. So we also have a variable in this data set that has years of experience with golf, and a scale score, kind of like your GRE score, of the enthusiasm, which is quantified by, it's a 1 to 7 scale, 1 to 7 scale is your previous golf experience, 1 to 7. And this miniature golf enthusiasm scale, which I believe we say, hey, you like miniature golf? And be like, yes, right? Like you just, yeah, I mean, like if there's nothing else to do, like did the liquor store run out of beer? I mean, sorry, never mind. The M-guess has been has been shown to, in previous research, to be a perfectly reliable measure. That's important because one of the assumptions of linear models is that our predictors and our predicted values are both perfectly reliable. If you're using a scale that's not perfectly reliable in a linear model, you're likely to have results that might be misleading, and therefore you might need something like structural equation modeling, confirmatory factor analysis, or Adams response theory to help what you're doing. That being said, M-guess has a mean of 0, standard deviation of 1. So we know where 0 is. It's the mean. So your task is to estimate one model, one single model, one LM statement that answers these specific research questions. And I will note this. When you get done with these classes, there's a tendency for you to say, well, I have this model where I put in my group as a main effect, but nothing else, and I use that to interpret the group effect. And I have this model where I put in experience, but nothing else, and I interpret it. No, we have to do one model that does everything. Otherwise, we're not controlling for the other variables simultaneously in the analysis. So we have one model to answer all of our questions. It may take a series of models to get to that final model that we're dealing with, but here we just have one, okay? And this model wants you to understand, to what extent do training group, experience, and enthusiasm each predict miniature golf performance? Right? So now you can think about it. Miniature golf performance is our dependent variable. Training group, that's a main effect, predictor. Experience, that's a predictor. Enthusiasm, that's a predictor. 1, 2, 3. All main effects. But then research question 2 asks, to what extent does the effect of training group depend on experience? Uh-oh. What is that? That is an interaction. Very good. An interaction between experience and the group you're in. So that is a product term. So that's the thing that makes life difficult. Now I will say why I believe very strongly in this assignment, even though it's a hard assignment, is because if you can if this can help you to understand interactions, you can go very, very far in your research. You can go much further than a lot of faculty members even do, because interactions and the main effects they moderate. In fact, how many of you went? We at EPSY, your students, I saw you. I went to there were a couple job talks this week, yesterday, and I went to both of them, and in both, the person presenting talked about moderation. I'm looking at moderating variables. Moderation is governed or quantified by an interaction, right? The extent to which the interacting variable changes the main effect of the one that you're interested in, moderates the effect of it. So this is a key research skill that is very, very difficult to acquire, but it takes practice and patience and so forth, and that's why I'm motivating this. So how do we set this up? Use the control group as the reference for training group. So what does that mean? Well, let's go back over to my R script. This is our example R code here. These are the names of the data that's currently as read in. We have a group variable. We have experience, enthusiasm, and score. So we know score is our dependent variable. Let's hold on for the second. To create the control group as a reference group, that means for it to be a dummy-coded variable, right? Let's go back. Those of you who watched lectures this week online, when you have a categorical predictor and you code the variables for it, how many coded variables get entered into the analysis? If we have 4 categories, we need 3 coded variables, right? So when we talk about the reference group, that's the group that gets left out in the coding, right? And why it becomes the reference group is because, again, the intercept now refers to the mean of that group, right? So if we leave the control group out, our intercept is going to refer to it being the mean of the control group And now whatever predictors also have to be 0 too. So this would be when experience equals 0 and when enthusiasm equals 0, right? So just remember that. So in this R code that I gave you, you can go to this section that says creating dummy-coded group variables. You just highlight this and run this. You'll see in your data file, your data frame, now we've created actually 4 group variables: group control, group many, group reg, and group both. Of course, my group control, just ignore that it's there. We only need to put group many, group reg, and group both into our analysis, right? And what you'll see, apart from group control, I'm laughing because of course I didn't put a 1 there. Group many is a 0 for everybody who is in a group that's not the miniature golf training group. And then once we get to everybody in the miniature golf training group, which group equals 2 in this case, you'll see a 1 there. Right? And so that's why I label it group many. It's kind of like a switch. If group many is 0, it means somebody's not in the miniature golf group. If group many is 1, then they are in the miniature golf group. Right? We have group reg doing the same thing. 0 for people who are not in the regular golf training group. 1 for people who are. So if we go down to observation 100 here, you'll start to see the 1s. Those are the people in group 3, the regular golf training group. So what does group both mean, do you think? What does a 0 for group both indicate? They're not in the both training group, the training group that received both. Thank you. What does a 1 indicate? They are in that group, yes. I know I'm sort of going slow here, but it's what we have to do. We need repetition, and we need this to work. I want this to click for everybody. So that creates the dummy codes for you. Then, going back to our description, it says use 4 as the centering point for experience. What do I mean by that? Well, if we go back to our data set over here, you'll note right up here, I'm creating an experience variable called experience4, which takes our regular experience that range from 1 to 7, and I subtract off 4 from it. Bless you. Does that make sense? Now, as to why we're subtracting off 4, buckle your seatbelts, because that's because the interactions of experience and group, for the group variable, the main effects now depend on where 0 is for experience. So when we get a main effect out of the computer that describes, the main effect of group many, it's specifically for where experience is at 0 point. And when we center experience at 4, that means an experience score of 4 is now our center point, or our 0, for taking experience minus 4. So for instance, experience 4 equals 0 when the original experience was equal to 4. Does that make sense? Ryan? That's right. That's a great question. So in a linear model, the main effects that come out of the computer are at the 0 point of the interacting variable. You have to do something to them to get the main effect for people who are negative. So for instance, one thing you might be interested in is, what about, let's imagine experience was in standard units, right? So now when we put 0, let's even go a step further and say the 0 value of 4 on experience was its mean, right? So let's talk about people 1 standard deviation from the mean. How would the main effect of miniature golf look for people 1 standard deviation from the mean? Well, you have to go in now and reconfigure the beta weights to give you that answer. And that's where, as we talked about in the lecture, the mult-comp package gets used. It's used for multiple comparisons. But there's a function in there called GLHT where you can go and put a pattern of the betas that you want in, and it will give you the answer that you're looking for. So it'll be able to tell you what the main effect for people -1 for experience 4 happen to be, or one unit below. So that's going to be the fun of this next 2 weeks. I know you're going to say it's frustrating. But actually, once you start to get the hang of it, it's really powerful. Like, you start to see interactions everywhere. The other thing you start to see is people interpreting interactions incorrectly. And not just anybody. You can point to journal articles where this happens. You can point to classes you've taken. How many of you have heard before, when there's an interaction in the model, we can forget our main effects? Right? You heard this. Bad, bad, bad advice. Because forgetting the main effect forgets the whole point of the interaction, which is moderation of the main effect. The main effect changes as a function of the other variable, is what the interaction is saying. So that's why we really want to hold on to that, okay? Isn't it nice to sort of talk about statistics a little bit more than just like read.csv? Sorry. I know it all gets overwhelming after a bit. So hang on there. Let's go through the rest of this. 0 is the centering point for enthusiasm. So that'd be, if we wanted to center enthusiasm at 0, we'd have to subtract 0 from it. So we don't have to do anything to it, right? And that's because, what does 0 mean for enthusiasm? 0 is the mean of enthusiasm. So we have a really understandable point where 0 happens to be. Okay, so specific estimates may be provided in the model or requested separately as needed. And this goes into talking about which each of the direction will matter for what you do. Let's go into this just a little bit more. So here, this linear model, let me just run all the code ahead of this, make sure I have it. The linear model code that you see down here is just a starter syntax. What do you think, after looking at the lectures from this, like, what does that mean? Score (1). I hear something. It's estimating the mean, which is just an intercept. That's right. It's an empty model. So that's not the model you want, although it's a good starting point for a lot of what we do. If we were to show that to you in the summary statement for the model object, you'll see the estimate of the intercept is 72.2635. And you'll note, again, that is the overall mean of score. That's the average score on this 18-hole championship-level miniature golf course. Okay. Sorry, I'm tongue-in-cheek saying that. You'll see that, by the way, if you're following along with your data, you're not going to get 72.2635. And that's because in the simulation process, there's some sampling error. So your result will be a different number than mine. Right? But you'll note the syntax that you put in will be similar. So let's do this. I'm going to start you off on a good foot. Let's build the model together for what this model should be, and then talk through it. Question?
Can you go over one more time what you did at the very beginning with the bringing the data in?
Okay, I can go over one more time what I brought the data in. Once again, putting this through, I create an empty R script file, and I save it into the folder where my data are located. Right, like that. I close RStudio. Kind of important to close it. We will have time to go through this in class on your own as well. So let me just talk you through it right now. Watch me do this. Think about it. Feel the words, and then we can practice on the time until class. We can open RStudio by double-clicking on the file that we just saved. When we open RStudio on a file saved in the folder with our data, the working directory of RStudio is the folder where our data exists. That means we don't need to put the full path to the data. We can just put the data file name in there. So now I go back to the website where I had my starter syntax. I copy it. I paste it into the homework 02 file. I save it. And I change the ID number at the top that's a single string of ones to be my ID number. 4228367, my social security number. That's right. Somebody with 4228367 and 2 other digits in their social is going to be pretty angry. All the steps I just did there I have to do before I run it in easily. But let's hold off on that for right now. And you can come back to it when we go through class in the class example. I really don't want to devote time apart from it. When we go through in the working section of class, that's what that's for. So hang on to that thought. Let's talk about the model, though. And this is where I'm going to go to the biggest piece of advice I can give you in homework on interactions or on interactions in general, which is the following. When working with a linear model, when building interactions, they take a lot of working memory to understand. Right? They take a lot of headspace. So for instance, I was trying to code this for you for the homework system this weekend, and my son throws a temper tantrum in the other room, and I'm like, it's gone, right? And I've been doing this for years, right? So it takes a while. The process I'd like to impart on you, where to start with all this, is to start by writing down the model itself, the way it should look, and then transferring that into R to make the syntax do what you want it to do statistically. Now this process that I'm going to describe is the same formula that I use when I do a linear regression. It's also the same formula that I use when I build a very complicated structural equation model or multi-level model. It's the same thing. So it's a good process to get the habit of, because the software that you're using, and if you hate R and you quit using it after this class, that's fine. It's up to you. But the reality of it is software is sort of stupid by itself. You have to know what you want out of it and what you to expect out of it, and you have to understand when it's not giving that to you to fix it. Okay? So let's talk about what the model is. We have a dependent variable that's score. I'm going to put score sub p. The p stands for person. So the score of a person is equal to what? I'll start. Intercept, beta 0. I like that one. Sound good? Let's add in then one of the main effects. And just to do this a little bit pedantically, a little bit routinely, let's start with one of the ones that doesn't involve an interaction. Enthusiasm. So we take beta 1 and we put enthusiasm. I'm just going to put it as ENTH, and I'll put a subscript P on it. Right? So that's the first effect we need in there. What is another main effect? Experience. So we could put beta 2 and call this EXP4 for experience, and the 4 represents we've centered it at 4. Okay. With me so far? Good. What's another main effect? Grouping. But grouping is more complicated because it's a group variable. It's not putting in one beta weight. It's putting in the beta weights for each of the dummy codes that have to go into the model. So we know that we have 3 variables that have to be entered into the model to make this work, right? So let's put in beta 3, beta 4, and over here, beta 5. Erase that. So I gave some space in between, and now I want to put the name of the variables I created to make that happen. And based on the instructions of the assignment, we have to put in to make the reference group the control group. So what are the 3 variables we need to put in? Group, many, right? Group, reg, and group, both. Right? So we put those 3 in. See how this is working? How are we doing? Does it make sense? Very good. Now we have all the main effects of the model in. We have 5 beta weights. But next, we need to add in the interactions. And what were the 2 interacting variables? Group and experience. Okay? So group is represented by 3 terms, right? All 3 of those have to interact with experience. So we get 3 more regression weights into our analysis. So if I add this to here, we get beta 6, beta 7, beta 8. And now what beta 6 would be the interaction between group many and exp4, or group many times exp4, and I can put a little subscript p on each of those for person. And similarly, beta 7 would be group reg for a person times exp4. And then beta 8 would be group both, can't spell, times exp4 for a person. So do you see why that's the case? When you have a grouping variable represented by a series of coded variables, when you put an interaction with it and some other term in, each of the coded variables have to interact with the other term. Yes, Mary Beth?
Can you just go over the different groups again? Because there are 4 groups.
Right, there are 4 groups in total. The grouping variable in R, pull this up real quick, group 1 was the control group.
And that's just the regular old instruction.
That's just regular, that's no instruction whatsoever in any golf. It's just like, you come in, you have some experience, some enthusiasm for mini golf, but you've never been trained through our special training program. Group 2 is the group that reflects those who receive training in miniature golf only. And that's group many. Group 3 is the group that received training in regular golf only. So that would be group reg. And group 4 is the group that received training in both miniature and regular golf. And that would be group both. Thank you. Other questions? Yes. Right, right. So the instructions say that the center point for enthusiasm should be 0. So if we were to center enthusiasm at 0, we would have to take the enthusiasm variable and subtract 0 from it. And subtracting 0 from a number gives us the number. So in effect, enthusiasm is already centered. The rationale for why that's the case is because this is a scale score. This is like a GRE score before it gets put onto the GRE scale. And it has a mean of 0 to begin with. So we know what 0 represents for it. There are people with 0 enthusiasm. Those people with 0 enthusiasm are people who are at the mean level of enthusiasm for miniature golf. So centering it at 0 is like centering it at the mean. That's right. 4 is an arbitrary number. It is in the middle of the scale from 1 to 7. But we do know that 0, if you note, if experience does not have 0 in the scale, when we look at the interaction of a variable with experience, if we didn't center it, that main effect that comes out of the computer refers to, the main effects of group refers to an experience that can't exist, right? So that's the reason why we put 4 in there. It's an arbitrary number, but it's right in the middle of where the... Well, let's think about the others. The others are categorical variables. And the purpose for centering is to understand what 0 means for each. So what does 0 mean for group many again? No, for this mini group variable that we created right here. What does 0 represent for it? It is somebody who is not in the miniature golf group. So we have already defined 0 in that group, so we're okay. So centering, because group many can either be a 0 or a 1, centering it is very different. The categorical variables, when we center them, we start to get nonsensical values just for almost everything. So we usually leave a 0, 1 coded variable as it is because we represent, when it's coded like that, we understand what 0 means. Does that help? Okay. Other questions? So, going back to the model, I didn't show this to you when I circled it. There's one other term I forgot to put in, which is, come on now, here we go, error. But error just shows up always, and we always say that error follows a normal distribution with some error variance attached. Yes?
How come you don't have to do interaction with enthusiasm?
Enthusiasm in group is not part of our research questions, so we left that out. That's right. Now, in practice, you might want to test for that. I can tell you, because I got to be the creator of the data, in this case, you don't need a test for it. It doesn't exist. But you may want to test for it in practice, if that were to be the case. And the reason for that is, if you remember in regression or linear models, if you leave out one of the beta weights that's influential in your model, you bias the other ones, right? So yes, good practice would be to test for it. For us right now, bless you, I'm leaving it off of this for now is to try to shorten the number of steps you have to do. There's already a significant number of steps, so I thought removing that from what would have to happen would be a little bit easier. So that's my rationale. Hope that helps. Other thoughts or questions? Okay, shall... Sir, I'm sorry, sir. Well,
Have you tried interacting, running this with interaction between
I have not tried. We can try if you'd like. Here, the next step I'm going to do is transfer this into R. Aggie.
Maybe a dumb question.
Not at all.
For B7, should there also be the P after the experience?
Yes, thank you very much. So, let me give you a little story. For those of you in the REMS program, I'm sort of a notation, I don't know what's the best to say, colonel, commander. There's a lot worse words for it, but I'm not going to say them out loud because they're not socially acceptable, right? I'm a jerk when it comes to notation, and the reason for that is, thank you for calling me on this, when I was in grad school, like many of you, notation for models for statistics is it's an entire language in and of itself. And not only that, it's a language that doesn't have a set alphabet because it's all contextual. If I draw beta on here, there's going to be someone who puts B on here, right? And we mean the same thing. However, that means if you're creating a notation system for yourself with your own context, you have to be consistent so people can understand it. And Maggie, that's exactly why that happens. And how I learned this the most was a trial by fire in my dissertation proposal defense, which at Illinois, when I went through, that was like your comps defense for the most part. That was the big meeting. If you fail that one, you're in trouble, right? I had terrible notation. And every slide I would put up with a model on it, which was pretty much every slide, because that's what I do, before I could even get 2 words out of my mouth, one of the professors in the room, Larry Hubert, who was fantastic as a professor, would start walking through the notation and saying where it was wrong. It got to the part where about an hour into a 2-hour talk, meeting, I sat down thinking, and I grabbed I had some water in a cooler. I just grabbed a water like it was a beer and started opening. I'm done. I'm going to fail. But it was a real formative experience to me. And why I say that to you is because it is such importance. And he said at the time, and it's one of his catchphrases, the 3 most important words in real estate are location, location, location. The 3 most important words in statistics are notation, notation, notation. And it's because if you don't write the notation right, then someone can't translate what you did to a reproducible result, right? So thank you. Not a stupid question at all. And if you catch me on this, thank you. I'll give you money or something like that. I'll start rewarding that. That's good behavior. So now let's transfer this into R, shall we? Now you'll note, even though your data changes and your results will change, sure enough, this will stay the same for all of you. I did not change the model up for each of you. So this code that I'm giving you right now is my attempt to get you started in a way that hits the ground running a little bit. Okay? So, for score, now I can delete the one or I can leave it in there. The one, I go into the LM section, and I'm going to put in the variables that correspond to what I just drew out here in my, my handwritten model itself. Okay? So now, score, I can leave the one in, it represents the intercept. I can delete it if I wanted to. But I hit plus, and the next thing I see is I need to put the enthusiasm variable in. And if I go and print out the names of the variables in my data, enthusiasm is called enthusiasm. So that's truth in naming right there. The next variable is experience 4. And in my data, that was named experience 4. To separate the main effects, I put a plus. And here, to make it a little bit more readable, I'll put spaces around the plus. So you can see what's happening. Does that make sense?
Do the spaces matter?
The spaces do not matter. They get stripped out by R before it gets run. The next effect I need is group many, group reg, and group both. And I'm putting them in the order I wrote them down. And the reason for that is when you start to do the questions of this homework assignment, you're going to have to do things with the beta weights as they come out. So you have to know the order they're in your model to get the right solutions as you come out, right? So when you write the model down, follow that, use that as your recipe for building your model. Okay? So group many comes next, which is called group many. We'll go to the next line, put a plus, and put group reg. Now again, you can continue this function on the next line without having a problem either. And put another plus, oops, and put group both. Now, finally, the last 3 effects are group many times exp4, group reg times exp4, and group both times exp4. And sure enough, in R, the times variable, if I put this in here, and put group many in, it's the asterisk. Right? It's the shift 8 on your, should be on your keyboard, unless you're using one of those awesome keyboards that I'm not used to. So I went to Montreal once for a conference, and I was at a workshop, and I was like typing on the international keyboard. Ugh, what's this? And it doesn't have to be international, I've learned. Okay, group many. The next one was group reg, asterisk experience 4. And then a plus, and then group both times experience 4. Okay, now let's double check. Remember, always good thing to double check, particularly because R is very strict about naming and everything else. We've got enthusiasm, experience, group many, group reg, group both. Enthusiasm, experience, group many, group reg, group both. We've got interaction of group many and experience, group reg and experience, and group both and experience. Group many and experience, group reg and experience, group both and experience. It should work. I hit Command Enter somewhere in there to run the line. I don't see any red. Hooray. I look at the summary, and sure enough, here are all my effects. Zoom in a little bit here. And sure enough, the way they are output in the summary is the order of the betas that I had in my model. I'm making a big point of this because to go and manipulate the betas as we go forward, we're going to have to understand which one there is. There are 9 total beta coefficients in our homework. Questions, anybody? Okay. So, see all those? Let me ask you, intrepid data hounds that you are. Data hounds, is that right? Data scientists, budding data scientists? No. I'm trying to think of a good academic jargon for that, be like a professor for once. Or a better, bewildered R users, is that? Sorry. I've been there. I understand. If you wanted to create the mean for the group many, when experience was 4 and enthusiasm was 0, how would you do that? What betas would you use? So once again, I want the mean score for golf is getting on the brain here. For group mini when experience exp4 equals 0, or experience is equal to 4, and enthusiasm equals 0. The answer lies in the beta coefficients and what they mean. Who wants to take a shot at that? Better yet, let's stop and let's talk about what the betas mean. What does beta 0 represent here? What does the intercept represent? The mean of the control group when enthusiasm is 0 and experience is 0. Or experience 4 is 0. So I'm going to talk about experience 4. When I say experience 4, that means 0 for that is the centered variable 0. I will try not to call it experience. I'll call it experience 4. Does that sound good? Okay. So when experience 4 is 0 and enthusiasm is 0, beta 0 represents the mean of the control group. What does beta 1 represent? Pardon me? It will represent the main effect. And in this case, because enthusiasm is a scaled or is a quantitative variable, we interpret it as a regression slope. So for every 1 unit increase in enthusiasm, a person's score goes up by beta 1 on average. Now, the question is, so that in this case, for every 1 unit increase in enthusiasm, a person's score actually goes down 5.22 strokes, which is actually a good thing. Meaning the more enthusiastic a person is, the better they're going to do at miniature golf. The better their scores are going to be, the lower their scores are going to be. Now, is that for a person in a given group? Is that for a person with a given experience? What I'm asking with those questions is that a simple main effect, which is also called a conditional main effect? Or is that an unconditional main effect? Does that apply to everybody? How many think conditional? How many think unconditional? The answer is unconditional, and the reason for that is the main effect of enthusiasm. Whoa, stop it, Templin. Pardon me. I press indiscriminately here. The main effect of enthusiasm, if you go and look for the rest of the model, thank you. Thank you. Enthusiasm does not appear in an interaction with anything. So when you have a variable that does not appear within an interaction with any other variable, it is unconditional. The effect applies to everyone. So this doesn't matter. So what we're saying is, if you look at my results, for every 1 unit increase in enthusiasm, people's scores go down by 5.22 points. That doesn't matter if you're in control group, miniature golf group, both, regular. Doesn't matter how much experience you've had. If you love miniature golf, you're going to do better at it. That's what it's saying, regardless of anything else. It's not conditional on anybody. Right.
This is a little aside. Why do we have the same summary? Shouldn't we all slightly different?
Everybody should be a little bit different. You have the same as I have? Oh, boy. Oh, dear. Well, I'll have to look into that. No. Yeah, I know. I will reset that as soon as I can. My apologies. Ryan. New data file. I can try to reset it over in the next few minutes. So, sorry. No, this is good. Is everybody getting the right answers? Yeah, well, guess what? That same process you're going to go through will give you different right answers. So it's going to be okay. All right. All right. I'll give it to you tonight. I will do that tonight. But this is a good thing. I apologize. I did not realize that was the case. I'm still working this out. Okay, next question. What does beta 2 represent? Main effective experience, but now again, its experience is a continuous variable. So, for every 1 unit increase in experience, and is beta 2 a conditional main effect or unconditional? How many say conditional? Conditional is correct. It's conditional because it appears in an interaction with another variable. So, beta 2 represents the main effective experience when the interacting variable is equal to 0. In this case, the interacting variable, there are 3 that we have to worry about: group many, group reg, and group both. All 3 of those have to be 0. What type of person is there that has all 3 being 0? As a control group person. So we're talking about the slope of experience here. This is the main effect. For every 1 unit increase in experience, scores go up by 0.05. Now it's non-significant, you'll note, but that is for anybody in the control group. Right? Right. So there is no effective experience for people in the control group. Pretty awesome. Am I right? Not really. Maybe? Okay. What is group? Let's go with group many now. What does beta 3 represent? Is it a conditional effect? How many say conditional? It is conditional, and that's because group many appears in interaction with exp4. So this is for everybody where exp4 is equal to 0. Or another way of putting it, if we go to the uncentered variable, anybody with an experience of 4. Right? So beta 3 represents the main effect of group many when exp4 is 0. And putting that into other words, group many, because it's a coded variable, represents a mean difference. Right? It's the mean difference between the reference group and group many's mean when experience 4 is 0. Right? So for all the people where experience 4 is 0, those in the miniature golf training group have an average score that's nearly 10 strokes lower than the control group. That's what we're saying.
What's the mean difference between the control group and the mini group
When experience 4 is 0, that's correct. That's correct. It's a conditional main effect. So, yes, Judy. Yes. Beta 3, or our group many main effect, represents the difference in mean between the control group and the miniature golf training group when experience, or for all of those where experience 4 is 0. Everybody see that? So let me go back to the original question that started all this. What is the mean score for someone in group many when experience 4 is 0 and enthusiasm is 0? Mean score for group many when experience 4 is 0 and enthusiasm is 0. How would we determine that from our model? Let's go with betas. Because the game plan, if you can understand the effect in betas first, then translating it to R goes much smoother. So what does beta 3 represent? It's the mean difference between group many and the control group. All right, so let's take a look at this. Beta 3 equals mean of group many minus mean of control. And I may actually have the effect wrong here. No, I got it right. So, right? Does everybody see that? So what is the mean of control? We know that. Mean of control is given by beta 0. Right? So now we can do a little bit of algebra. Nobody said there'd be algebra in this class. It's always with us. It's like the Matrix. You wake up in that movie, It used to be good. Then they ruined it with a third one. Anyway. Right? So if we have the mean of group many minus beta 0, or beta 3 equals mean of group many minus beta 0, if we go and add beta 0 to both sides, we get beta 0 plus beta 3 gives us the mean of group many. So now we know the mean for group many, again, with experience 4 equals 0, with enthusiasm being 0, is beta 0 plus beta 3. See how that works? Kind of working the breadcrumbs backwards. Now let's use R to figure out how to get that out of the computer. Here we go. In the bottom part of the R syntax, there's this long set of zeros embedded in a matrix function. And I call it question X. Just said a...
Before you go through that, I just want to double check.
Yeah.
So, when you're talking about how you're adding B0 and B3, and that's when enthusiasm 4 is 0, experience 4 is 0, and enthusiasm is 0.
Right.
Do you also have to say, and the interaction is not being accounted for, or not because it's 0?
It's because when you say these are 0, you've put the condition in where you don't have to mention the interaction. Exactly. That's exactly it. So when you put a 0 there, it's like literally, if you go back to your regression line, it's like literally putting a 0 for here for enthusiasm, here for experience 4, but then in all the other places where experience 4 shows up, there's a 0 as well. And you just erase all of those altogether. You know that group reg is a 0, and you know that group both is a 0 because for person in the mini group golf, those have to be 0. So now all of a sudden the only terms left are beta 0 and beta 3. So that's a very good lead-in. Does everybody see what we're talking about here? Right? So the key to everything in this, and the key to everything in the analysis you're doing, is understanding the model you're running and the reality of what it means for different types of people. So let's go and try to make it so that beta 0 and beta 3 comes out, and we get the R to add this up for us. And the reason for that is, well, I'll get to the reason in just a moment. Right? We don't get the mean directly from the output, but we can get it from our betas. So the GLHT function, which is at the bottom, requires you to form a contrast. Have you heard of contrasts in regressions before? Contrasts are like what we have here in our script. It basically says take sum of beta 0 and sum of beta 3 and add them together. And the zeros that you see represented in the highlighted R syntax there are the amounts of beta 0 and beta 3 and all the betas that show up that we want to add together. Right? So right now, if I were to run this contrast, there's a 0 for every beta weight. So the sum of that would give us a big 0. The machine would probably break. Let me see if it would break. Yep. Big old error, something's wrong. That's because nothing from nothing leaves nothing, right? You have no effect there. Now, what you'll note is there are 9 zeros here. There are 9 betas in our model. That is not a coincidence. Every beta has to have a weight going into this contrast. And what we wanted were beta 0 and beta 3. And you'll note our numbering system of betas started with beta 0 as an intercept and went up to beta 8. So that really means the very first spot on here is actually going to correspond to the first number that came out of the computer, which is what we're calling beta 0. So if I put a 1 there, it will give me the intercept back. Because 1 times beta 0 plus 0 times all the other betas just gives us the intercept. So now I need to go to the spot where beta 3 is. Now, again, beta 3 is the 4th beta in our model because we started with counting with 0. So 1, 2, 3, 4 betas down. The 4th 0 in, I convert to a 1. And now what we can see if I run this is that it tells me the mean is 65.10. Does that sound accurate? Let's find out. We knew from the intercept of the data was the mean of the control group when enthusiasm and experience were 0. And that was 74. And we knew that the mean of the mini golf group when enthusiasm was 0 and experience 4 was 0 was about 9.87 less than the mean of the control group. And sure enough, 9.87 less than 74.97 is 65. And that gives us the mean we want. How about that? You are going to tell R who's boss. That's right. Maggie.
So what do you do? So you put in the ones in the first and the fourth instance.
That's right.
And then do you run it?
And then what you do, so let me go back to the syntax. So this loads up just a vector of ones in R, a matrix of ones. And it gives us a name. You can actually name it whatever you want. Here I can put in mean mini, exp4 equals 0 equals 0. So I can give it a name. You run that line, you run the following lines, but really what you do is you end up submitting this questions object. If you have more than one, like if I wanted the mean of the regular golf group, so I call this question x2 or something like that, instead of the third beta weight or the fourth one on here, I just put a 1 over in the next spot, right? The same process. And I can put question x2 right after rbind there. So this questions object is now a matrix of each of these contrasts that show up. Actually, let me run that again. So this is now the matrix of contrasts. And here, I submit that matrix of contrast to the GLHT function with my model, and it gives me the numbers I'd like. Ryan.
So you're creating
A vector of essentially weights for the betas.
putting those vectors into a matrix.
And for every row of that matrix, it's going to give you a number that represents the contrast that you want. Exactly. You could layer that very first part of homework that has 18 questions. If you wanted to, you could create 18 rows to that matrix. You don't have to, though. Some of those you can just get directly from output. Now, I've taken a lot of time to describe this, but I wanted to get you to start in the right direction. When I'm going to stop talking in just one moment. I'm going to first describe a couple other things. Number one, so you've got homework 2. You've got what to expect. And again, I would ask that you compute questions 1 through 18 before you attempt the results section questions that you see below. Because once you create the questions 1 through 18, the results sections will then have the right data in it to read the results. Next. There is today, if you really wanted to take your time away from homework, although I doubt any of you will, there's an in-class example today also on interactions, on more of them. And I will tell you that if you get stuck with this, I would also refer you to the reading of the week, chapter 2 from Lisa's book. It's quite good about describing the interaction effects, what we're talking about here. Most of the stat readings I don't care much about, but she's a great writer, and this is a great, I'm biased, of course, because I like to live indoors, but I'm already once divorced. But beyond that, actually there's some really good merit to what she does. She's very good at describing this. This is her bread and butter of what she does. Oh, bread and butter. This is where she earns her living right here, right? So I would refer you to that chapter. It does help a lot. It takes a lot of people from kind of where you're at if you just took the regression class to a lot more advanced state as you go forward. And you'll also note that book actually is a book on multi-level models and longitudinal analysis, right? But it starts here. It starts with interaction. It starts with the linear model. So I'm going to stop now. You're welcome to get up, use the restroom, whatever. The class is going to go till about 4:20. I won't have another reconvening because I'm expecting you to probably work on homework. If you're working on homework and I end up changing the data later on, just your syntax file will work the same, right? Just make comments to yourself as to which question it works and just use this one for right now. Later tonight, you will see whatever you put in for this data will have disappeared and you'll have to go and retry your data. I'll send an email to the group when that happens. I apologize for not getting this straight. Yes, Sammy.
Are you going to go over the quiz?
Oh, the quiz. Other questions. Yes, I can do that. Quiz, first of all, I will note on the conversations this week, we had some questions about homework in here. Please don't post homework questions there. I won't look for them there. I mean, you can. I guess you can post them, but don't expect me to reply to them there. Please just send me an email about the homework if you have it. The quiz itself, let's go through those quiz questions. Quiz 2. Begin. Question number 1. Here we go. Here's the hypothetical model. What can we say about the main effect of x? This is asking you whether or not the main effect is conditional or unconditional, effectively. I have not enabled it yet, I guess, so I'll have to re-enable that also when we get to the break. So the main effect of x, going back to that, the answer to this is it's a conditional main effect. X appears in interaction with z, so this main effect only applies, beta 1 only applies to those who have z equal to 0, because it's part of that interaction. Same thing for the next question. What is about the main effect of z? Because it appears in an interaction with x. It's conditional as well. It only applies to those where x equals 0. Other thoughts or questions? Yes, Juhi. No. Aisha.
Sorry. Is each quiz worth 1 point or each quiz worth 2?
It should be worth 2 points each. If I didn't get that right, I will work that through. No, the total should be 2 points each.
On
The homework website will not be updated to date. It only populates once I update it. So whatever is in Blackboard is accurate for your grade. Okay? Other questions or thoughts? Yes?
Not about the quiz, but could you please show us again the syntax to create the matrix?
Yes. Right here? So here, in the syntax that you have, if you just copy this as a template, copy that line, configure the betas that you think go into that effect by putting 1s and 0s into the right spot. You could even provide them a name in the quotes at the end of the line, and then run the syntax down through summary effects. It will load up the right contrast into the right form it needs to be to get the answers you need to make this work. Other questions?
Will the homework get less challenging from now on?
Yes, actually yes. This one is challenging, but remember, this is material that's like the entry point to so much else. And so why I have that here, why I firmly believe in it, is because it really does help elevate your ceiling once you work on it. And the only way to learn it is to be challenged with it. This is not like, and maybe you'll correct me on this, it's not like some like athletic ability like golf where some people seem to be born with the ability to do it. Every one of us who goes through this is challenged by this. And even the instructor who understands conceptually what it means, who's done it for years, still has challenge trying to think through it. It takes a lot of working memory. So yes, it will be challenging, but just realize this is your first real way of putting it together. As you go on in the models that you might want to run that become quickly, you run out of ways that you use a linear model. Almost all of them will have the interactions present. So this is kind of a gateway to understanding more in statistics. But I do structure the homeworks a little bit easier. But I'm trying to help you, trying to minimize what you're learning in here so you can focus on understanding what I think is a real gateway skill to going forward. And of course, you're not alone. You have each other. You have us. All right. So you know how to find us. Other thoughts or questions? Okay, I'll stop here. I'm not going to reconvene. You can work here up until 4:20. I'll just work your way through, and we'll go from there. Oh, a question? Okay, all right. We can start the process.